Welcome back, everyone. This is the heat treating episode for this pair of knives. This is my Paragon 24-inch double barrel kiln with the argon flood kit, argon purge. There's a flow meter on the side of the oven installed by Paragon. And over here is my Victor TIG flow meter. And this is much the better of the two. It renders the one on the oven pretty much irrelevant, but I still use the oven one to fine-tune a little bit here and there. You can see I'm at 12 cubic feet per hour, which seems to do a pretty good job of getting most of the scale and decarb. So right now I'm just quenching a big preheated piece of steel into my Parks 50 to preheat it to get a better quench, because it's like 40 to 50 degrees in the shop, even with the wood stove going for a little while already. Even in the summer, I usually will like to preheat my Parks because you just get a better quench out of it. Lots of stirring. Getting all that nasty roasted Parks 50 oil smell all over my coat. My wife loves it. She said I smell like a dead robot when I come in the house after quenching. Just lovely. Right now I'm normalizing these. So I brought them up to temp, soaked them for a minute, and now I'm just going to air cool them down to 700-800 degrees just to set them up for the quench and remove any residual grind warp or grind stress. And here we're quenching. Gotta get in there nice and quick and agitate it up and down, back and forth, not side to side. And pull it out once I've got down past the perlite nose all over, but I'm still at several hundred degrees, smoking hot. Flip it over, give the bolster some extended quench time because I don't want the added thermal mass of the bolster getting any auto temper down into my blade. Now I'm going to finish mopping that oil off. Got a pretty good scale break there. That's always a good sign when most of it slides off rather than sticks on. And I'm going to visually inspect it, make sure everything is straight. Didn't warp in the quench. If it did warp, it's still hot enough that I can tweak it straight with these heavy gloves on. So that one looked good right out of the oil. Going right into blade number 2. This is the tall bunka. So get that count done, pull it out. Again, mop it up, flip it over, get the bolster a little bit more. So that bolster is still a few hundred degrees hotter than the blade, and the heat from that will bleed down toward the heel of your blade if you don't watch out. Now, with me pulling them out of the oil before they get down to martensite finish, or even martensite start, really, they will inevitably auto-temper a little bit. So as quenched, you don't get as high of Rockwell readings, but after temper, it evens out. I temper them at a little bit lower of a temperature, and it evens out. I can still get nice hard blades, but I get much less warping this way and much more fixable warping if it does happen. This is particularly useful with sandmai blades that might want to rip down the center of the core. I'll do an episode on that sometime too. I'm just sighting from the tip, tweak it a little bit. It's pretty easy to bend before it starts to harden. And this is just a 15N20 1080 Damascus. Nice and simple to heat treat. Responds really well to Parks 50. I always check that first one again, because sometimes as it continues to cool there, it'll start to warp a little bit. And you want to catch that while you can still fix it. particularly the tang needs to be in line with the blade, and it'll kind of kink to the side sometimes after you've set it down. Both of these blades did just fine though, barely needed anything. And so now I'll let them cool. They went into the shop oven or into the house oven for a snap temper. And then I put them in the shop oven here again for their finish temper cycles at 330 degrees. 2 cycles of 330 degrees. So they're done tempering. I have a quick flyby of the pattern poking through the scale here. I always have fun seeing that. Surface grinder time. Of course, we're back here at the old abrasive 3B surface grinder. I got a 120 grit ceramic belt on there. And I'm going to take 5/1000ths of an inch off each side, which in my experience is enough to get through the decarb layer and give me a decent surface finish to get an accurate Rockwell test. I put them at an angle on the chuck there, of course, because I can't be running into the bolster. And I want to get the whole blade on the chuck as much as possible up to the bolster. And then I'll just grind that remaining little triangle off in front of the bolster on both sides. There's my 120 grit on one side. And that'll bow it like a banana, taking that decarb off one side all at one time. Enough to freak you out, but so I'm checking my thickness just to see where I'm at. And then I'll take that 5 thou off the other side, and it'll bring that warp back out of it. With that done, over at the Rockwell machine here, I perform a few of these tests on the calibrating block first, just to make sure the machine is in trim, testing accurately enough, and if not, how far off is it. The machine was testing a little bit hard right now, which is, it's common if it's a little cold in the shop. The dampening oil gets more viscous, so I took that into account. It was testing almost 63 when it should be reading 62.1, so I adjusted all of my average test results down a bit accordingly. So here we are testing a blade. It always takes a couple of tests to even eliminate outliers from things in the machine adjusting to the new thickness. So you take 5, maybe 6 tests and average the results out over slightly different areas of the blade. We've got our initial load, secondary load, and now we're seeing what the difference between the two is. The first one's like a 61 Rockwell, which was a little low as I expected. Usually the first test will be a little low. It's rare to have an inaccurate test be a too high reading. Here's a close-up. We're coming around, applying the secondary load, watching the needle settle. And now we crank it back, lock it again. Now it's getting readings of 63, 63.5 at the highest. We're going to do another test. I really enjoy actually using the Rockwell tester. It's pretty fun in person, at least for a knife maker like me. I mean, I'm sure for a lot of people it's like watching paint dry, but after I got this thing, everything in sight near the tester was dimpled. Little test dimples. There's another 63 test, so I ended up just averaging it out after several tests to being 62.5. A lot of heat treating companies would characterize that as Rockwell 62 to 63. They usually give it a 1-point range. But anyway, that's about what I wanted. 62 to 63 is where I like these to be. So success there, and thanks for watching along with me. Stay tuned for more.